All right, welcome to our last video of this series. This is day 6, writing quadratic equations. Now I'm going to be very specific about the requirements for these last few problems. 26 and 27, those would be ones that I would allow you to use Desmos. And even number 27 specifically says use technology. So we'll talk about that in a second. Number 20, excuse me, number 26, I'm going to allow you to use technology on this one too. I would totally use this in Desmos probably. And what I would do is I would make an XY table for myself that I could go put into Desmos. I don't know why I drew that right there. Let me go scooch that over a little bit. All right, so I'm going to make an XY table. All right, I'm going to go find at least 5 points. 3 would probably be okay, but I'm going to do 5 that would exist for this guy. So it looks like this is a point, this is a point, the vertex is clearly a point, and then of course those guys, reflection buddies, are points as well. So I know that these 5 points exist on the parabola. So -3, 1, -2, 4. I always like to go left to right. So it doesn't really matter what order you put yours in. I just like to go least to greatest in my x's. And then 0, 4, and 1, 1. And so now that I have these 5, I'm just going to go put my table in Desmos, and I'm going to go run a quadratic regression. Okay. Hold on, give me one sec. Okay. Uh-oh. Okay. I'm going to take a picture of that. Okay, so I'm going to go to Desmos. Okay, I'm going to clear out that last problem that we did a second ago. I'm going to go add table. Then I'm going to type in -3, -2, and then it should fill in the rest of them for me. There it goes. And then 1, 4, 5, 4, 1. And then once I have my table filled in, I'm going to go ask it to run a regression. I don't want a linear regression though. I want a quadratic regression, right? And so that is going to give me this lovely equation right here, right? And so that would, to me, that's going to be the easiest way for us to answer that question. And I'm totally fine with using Desmos on the test for that. So I'm going to write y equals, I'm just going to type over what I got on Desmos. So -1x squared minus 2x plus 4. And voila, easy peasy. Okay. All right, then we're going to go to our next question, which is basically the same thing, except this one, it does say use technology to write the quadratic equation that best fits the data below. So this is going to be a scatter plot, right? So we are going to be doing a quadratic regression. So it says round all values to the 100th place. So we're going to go to 2 decimal places. Right, so I'm just going to write that down in case anybody needs a refresher, right? Hundredths is the 2nd decimal place, right? So 2 decimal places. Okay, so here we go. Back to Desmos. I'm going to clear out all that and add a new table. All right, let's put in these values. So we've got 0, 1, 2, 3, 4, 5, 6 as our x's, and then 9, 7, 3, 4, 8, 10, and 19. Oops. Oh my God, I did it again. There we go. All right, I'm going to go kind of maneuver my graph. So it definitely looks like a quadratic overall, right? We're doing a best fit quadratic function, but our eye definitely does follow a U-shaped graph when we look at that scatter plot. So we're going to go tell it to run a quadratic regression. And there we have it, right? So notice it's all these gross decimals that go out infinitely, I'm sure, right? But we're going to round that to 2 decimal places everywhere. So I'm going to go back here. And so our equation is y equals 1.08, because it was 1.083333 x squared minus 5.04, because it said 3.5, so the 5 would round it up, and then plus 9 point. Now on Desmos it says 9.595, which would the third 5 would round the 9 up to a 0. So this would actually go up to 9.6. Right? And there you have it, right? The best fit quadratic for that data. All right. Now that our very last page, finally. Now, the heads up I want to give you guys about this last page is no Desmos. You can use Desmos to check your answer, but you must have work. Show all work. If you don't have work and you just use Desmos, then you are not going to get credit, right? So I'm just going to give you the heads up right now in this video that you have to show your work, okay? All right, here we go. Writing equations given different information. So it says, write the equation of the parabola whose roots, all right, remember roots are solutions or x-intercepts, are x equals 2 and x equals -5. All right, so what we're going to do is we are going to transform those solutions back into the factors that they were. So we're going to move we're going to move the 2 back over to the other side by subtracting it, and that gives us x minus 2 equals 0. That means that x minus 2 was one of the factors. If we were to take the original problem and put it back in factored form, x minus 2 was one of the factors, since that factor gave us the solution of x equals 2. Right, we're going in reverse, right? And then we go to the other solution. So that means we're going to take that -5, we're going to move it back over. So that would give us x plus 5 equals 0, which means that x plus 5 was one of the factors. And you guys, that technically, I'm going to throw a little y equals in front of that. That is your function, right? That gives us those two equations. We're just not done though, because it says standard form, right? And standard form means I need to multiply this out, right? So we're going to multiply these binomials. I'm just going to write these steps out because it's not a difficult problem. It's just a lot of steps to remember. So we're going to multiply the binomials. Right? So again, that means you're either going to double distribute or you are going to do the box method, right? And so whichever method you choose is totally up to you. I'm going to copy that and bring that down so I can kind of mess with it. All right, so I'm going to just double distribute. So I'm going to do x times x and then x times 5, which is going to give me x squared plus 5x. And then I'm going to do -2 times x and -2 times 5, which is going to give me -2x minus 10. And then, of course, we have those like terms in the middle that we'll be able to combine. 5x's minus 2x's is 3x's. And voila. And I'm going to bring my little y equals down. And there you have it. There is our function that gives us those two solutions. Now, you know I'm going to check my math in Desmos, right, just to make sure that it didn't make a silly, careless mistake along the way. All right, so I'm going to go type in x squared plus 3x minus 10. X squared plus 3x minus 10. And I'm going to go check those solutions. What do you know? -5 and 2, just like they gave us at the very beginning of the problem. Okay, now on your test, you have to show all of this work, right? Don't be trying to run a regression or do any of that work, right? I'm checking to make sure that you know how to go from solutions and then go backwards to bring it back to standard form, okay? All right, number 29 is basically the exact same except with a twist, right? Some of you guys did not understand this twist when I graded your day 6 homework. If you go back and look at your day 6 homework, over half of y'all did this incorrectly when you had fractions. Even though we did a couple of these in our notes and talked about them at length, you missed all these questions on your homework. Anyway, so let's make sure we're paying close attention here. All right, so I know I'm going to do the exact same thing I just did, right? I'm going to take 3/4 and I'm going to move it to the other side. So that's going to give me x minus 3/4 equals 0. I'm going to go ahead and do the other guy also while I'm at it. Now the other solution was negative, which means when I move him back over, he's going to be positive 2/5 when I move him back to the other side. Now this next step is what a lot of y'all failed to do. So I'm going to kind of put the instructions over here to the side. When you are putting something in standard form, guys, we don't want fractions. We do not want fractions in our factored form. That's not correct, right? So you need to get rid of the fractions right here. Get rid of the fractions, right? You should not have any fractions in your parentheses when you start multiplying. Well, how do we get rid of the fractions? Well, I'm trying to get rid of this divide by 4. So I'm going to multiply every term by 4, right? Because that means these 4s are going to cancel, but everybody else has to get multiplied by 4, right? So that's going to give me 4x minus 3, because there's still a 3 up top. And then, of course, 0 times 4 is still 0, right? So my actual factor was 4x minus 3, not x minus 3/4. Right? I cannot stress that enough. Okay, 4x minus 3. All right, we're going to do the same thing on the other guy. He's got a denominator of 5 that I need to get rid of. So I'm going to multiply everybody by 5 to get rid of his denominator, which is going to leave us with, sorry, I'm trying to draw an arrow, 5x plus 2 equals 0. And that tells me that my factor was 5x plus 2. Right? You throw a little y equals in front of that mess, and that is your two binomial factors that produce those solutions in the first place. Right? And now we're going to do what we just did a second ago. Now that we've gotten rid of all the fractions and they just look like normal factors, right? We're going to multiply the binomials. All right, so here we go, just like I did on the other one. I'm going to bring it down here so I can mess with it a little bit. All right, so here we go. I'm just going to multiply all this out. So I'm going to multiply 4x times 5x, which is going to give me 20x squared. And then times 2 is going to give me 8x. Then I'm going to multiply my negative 3 times 5x and 2, which is going to give me negative 15x minus 6. And then I'm going to combine my middle like terms, which is going to give me negative 7x's in the middle. And then, of course, I'm going to bring my y equals down to make it a function. If you forget your y equals, I am going to take a point off, right? If you give me an answer that's an expression and not a function equation, then that is technically incorrect, right? It has to have a y equals on it to be a function. All right, and that should be my answer. Now, you know I'm going to go into Desmos, and I'm going to type that in and just make doubly sure that that this function does, in fact, give me the solutions of 3/4 and negative 2/5. So here we go. Y equals 20x squared minus 7x minus 6. All right, let me blow this up just a little bit. And I'm going to go in here. Oh, negative 0.4, right? That would be the negative 2/5. And if you're not sure about your fractions, you can always type them in over here. Oops. There we go. All right, so negative 2/5 is negative 0.4, and that's exactly what I was supposed to get there. And then our other solution is 0.75, which is, of course, what 3/4 is as a fraction. And you can double check that in Desmos as well. Right, so remember Desmos is only going to give you decimals, right? So you can type in those fractions and they're equivalent. Yay! All right. Last one. All right, so number 30. This is kind of a long one because it wants you to write it in vertex form and in standard form. All right, so I'm going to run through this really quick. So basically, this question right here is day 5. So we've got our HK, we've got our XY. Didn't we already do this one earlier? Negative 3, negative 6. Hold on, I'm going to go back. nope, that was a different one. Okay, that's okay. All right, so here we go. So y equals a x minus h squared plus k. So let's see, our y is -2. A is what we're looking for. -2 plus 3, because the double negative with that h value, minus 6. All right, we got to do all this. Put that in front. So -2 equals, that's going to give me 1 squared, which is just 1. So my multiplier on my a is just 1, so I'm going to keep that there. So all I need to do is add the 6 over. So I'm going to get an a value of 4. Awesome. That means my vertex form is y equals 4 x plus 3 squared minus 6. All right, before I go any further, I am going to go double check that in Desmos to make sure I didn't make a silly mistake. Right? So y equals 4 x plus 3 squared minus 6. Let me get back over here. And let's see, a vertex of -3, -6. Yes, and we also wanted it to go through the point -2, -2. So let's double check that. Label it. Yay, right? So he's got all the points on there that I wanted to, so I know that that's correct. Good. Okay, now I'm going to take that vertex form and I'm going to convert it into standard form, right? We did this quite a bit. So remember, you need to do this part first. All right, I'm even going to go off to the side and I'm going to do the x plus 3 squared, because remember, parentheses and exponents have to be taken care of first. So remember, x plus 3 squared needs to be expanded into x plus 3 times itself, and then you need to double distribute. Again, or you can do box method if you want to, and that's going to give me x squared plus 6x plus 9. So now when I come over here, instead of 4 times all that, I'm going to type in x squared plus 6x plus 9 because I already expanded and multiplied out that x plus 3 squared. And this looks much better because now I just need to distribute the 4 to everybody inside that trinomial that I just got earlier. So that's going to give me 4x squared plus 24x plus 36, and then I don't want to forget that minus 6 hanging off the end, which is going to give us 4x squared plus 24x plus 30, right, when we combine those like terms. And that, I'll just copy and paste that. That should be my final answer that goes here, standard form. Now, you know I'm going to go check that really quick by going to put that in the Desmos. Since I already had the other function in there, I should put my new one, which is the same quadratic. It's just written in a different format. So they should overlap on top of each other if I did it correctly. And I'm going to change this color to red. All right. So notice I can toggle back and forth, blue, red, blue, red, blue, red, and they're the exact same function, which means I did not make a mistake putting him into standard form. Woof. All right, you guys, that is all of our Unit 7 review. I hope you are getting yourself ready for the test, and if you have any questions, just come in before or after school. All right, good luck, you guys.